This is Pre-Calc, section 11.3, geometric sequences in series. A geometric sequence is one in which each term after the first is obtained by multiplying the preceding term by a constant non-zero real number called the common ratio r. Remember, arithmetic sequence in series, each new term was obtained by adding or subtracting a number. Now we're going to multiply by a non-zero common ratio. So 1, 2, 4, 8 is a geometric sequence with a ratio of 2 because 2 times 1 is 2, 2 times 2 is 4, etc. One of the first things you're going to be asked to find is to find the common ratio, and sometimes it's very obvious what the common ratio is. You should be able to see that what you're doing to get from 5 up to 15 is you are multiplying by 3. 3 times 5 is 15, 3 times 15 is 45, 3 times 45 is 135, which makes your common ratio equal to 3. Sometimes it's not so obvious what the common ratio is. So the common ratio can be found by choosing any term after the first and dividing it by the preceding term. What that says is take the second term and divide it by the first. 22 divided by 8 is either the fraction 11/4, or you can change it to the decimal 2.75, depending on what Math Lab is asking you for. So sometimes the common ratio is obvious. Sometimes you have to do a little bit of arithmetic to come up with the common ratio. You're asked to find the first 5 terms of this geometric sequence with this information. A sub 1 is 3, and the common ratio is -4. That means multiply 3 by -4 gives me -12. Multiply by -4 again gives me +48. Multiply by -4 again, -192. Multiply by -4 again, and we end up with 768. So that's just simple arithmetic using your calculator, starting with A1 and multiplying successively by the common ratio. Now this one asked me for the 8th term of this sequence. Now I could count out to 8. Pretend I asked you for the 18th or the 80th. Well, you don't want to count all the way out there. So there is a formula right here for the nth term of a geometric sequence. You need to memorize this, and you need to be able to distinguish this geometric sequence formula from the 3 arithmetic formulas we learned in the previous section. So to find the 8th term, I would say a sub 8 equals a1, which is 3, times the common ratio, which we established to be -4, and you need to put that in parentheses if it's a negative ratio, raised to the n minus 1 power. Well, n was 8, 8 minus 1 is 7. Be careful arithmetic-wise. You may be tempted to multiply 3 times -4, but you cannot do that. Order of operation says I need to raise -4 to the 7th power before I multiply it by 3. But your calculator will do this directly for you, but just be sure you have parentheses around that -4. So 3 times the quantity, -4 raised to the 7th power, is 49,152, would be the 8th term. Notice in a geometric sequence how quickly the terms get large because you are multiplying each time rather than adding or subtracting. So find the 8th term of this sequence using the formula. Would be a sub 8 equals a1, which is 1, times the common ratio. What are you doing to get from 1 up to 3 up to 9? You are multiplying by 3, so the common ratio is 3. Because that's a +3, I'm not worried about putting it in parentheses. Raising it to the 7th power, you can type that in your calculator, and you will find that the 8th term of that sequence is 2,187. Find a sub 5 and a sub n for this information. Well, before we start working over here, let's take a look and see if we can figure out the common ratio. Common ratio here is -3, because 4 times -3 is -12, -3 times -12 is 36, and so on. So to find a sub 5, I would, because I've already got out the 4 terms, to find a sub 5, I would just multiply by -3 one more time, would give me +324. Now, if that had asked me for a sub 15, then I would have used the formula. So I'm not going to use the formula for that, but for a sub n now, I have a sub n equals a sub 1, which is 4, times the ratio, which is -3. I need to put that in parentheses, raised to the n minus 1 power. And that is my formula. I can't multiply 4 times a -3 because I have to follow order of operations, which is raise -3 to this. So that's what you're doing. When you're asked to find a sub n in this situation, you are coming up with a formula. Find R and A sub 1 for the geometric sequence with the third term of 20 and the sixth term of 160. The book way on this is to do two equations and then solve them, like with elimination. What I like to do instead is to lay out a couple blanks. The third term is 20, so I have blank blank 20, and then fourth, fifth, sixth term is 160. So I want to find the R and the A1 for this. Well, just for a second, I'm going to pretend that A1 was really 20. And if that's the case, this is my pretend A1, this is my pretend A4. I can use the geometric formula, A sub n equals A sub 1 R to the n minus 1. So in my little scenario here where I'm pretending this is all I have, we're talking about A sub 4 being 160. A1 is 20. The R I don't know, but I do know from my little partial sequence here that there are 1, 2, 3, 4 terms. So this is raised to the third power because 4 minus 1 is 3. Divide both sides by 20, and I get 8 equals R cubed, which means R is 2. So I found the common ratio pretty easily. They also want me to find A sub 1, and the easy way to find A sub 1 is to work backwards this way. Going this way with a common ratio of 2, I multiply by 2 gives me 40. Multiply by 2 gives me 80. Not that they asked me for those, but going in this direction we are multiplying. When I go backwards this way, I would divide. 20 divided by 2 gives me 10. 10 divided by 2 gives me 5. So A sub 1 is 5. So that's kind of more of a reasoning way to do the problem rather than strict equations. Now, a geometric series is the sum of the terms of a geometric sequence. We've done this before with arithmetic, but we have this formula. So it's another formula to memorize. So far, you have 3 formulas related to arithmetic sequence and series, and this is our second formula related to geometric sequence and series. So one other little thing just to point out, of course, this is only valid if r does not equal 1 because you cannot have a 0 in the denominator here. Now you're being asked to find the sum of the first 6 terms of this geometric series. Let's go ahead and figure out what the ratio is. What you are multiplying to get 10 from 2 is 5. So we're doing S sub 6. It equals A1, which is 2, times 1 minus 5 to the 6, because that n and that n are the same, all over 1 minus 5, because that r and that r are the same. Now what I would suggest you do is at least do one little thing before you really hit the calculator hard, and that is 1 minus 5 is negative 4. Because what you can do now is, this is exactly calculator steps. 2, parentheses, 1 minus 5, caret 6, close your parentheses, hit enter, and whatever number that is on your screen, leave it there, and then divide that by negative 4. And that comes out to be 7,812. Asked to find the sum of this geometric sequence, and we know that it's geometric because of the format. When you have something to a power, that tells you that it is geometric. Not only does that tell you it's geometric, that number right there is your common ratio. So that makes plugging in a little bit easier. We're doing S sub 6 equals A1, which I have to figure out. A1 will be when I put 1 in for I. 3 to the first is 3, times 2 is 6. So this is 6 times 1 minus the ratio of 3 raised to the 6th power, close your parentheses, over 1 minus 3. If you want to do a lot of this on the calculator, you could put parentheses around the 1 minus 3, and you could enter in your calculator this, 6 parentheses 1 minus 3, caret 6, close the parentheses, enter, and then divided by parentheses 1 minus 3. In my opinion, 1 minus 3 is negative 2. That's easier to deal with. But your ratio could be something like 5/7 or something, and you'd rather have 1 minus 5/7 right there. And when you type that in, you're going to get 2,184. Now, we're going to deal with something called an infinite geometric series. And you might think, if it's infinite, how can you find the sum? Well, we can only find the sum of an infinite geometric series if the absolute value of the common ratio is less than 1. And if that's the case, we say that the sum converges to that particular number. So take a look at 2. 1, 1/2, 1/4, 1/8. Notice that these numbers get smaller and smaller. This common ratio is a half. Because the absolute value of that ratio is a half, that tells me that we are going to find the sum of this geometric series. Before I give you the formula, let's see if we can figure out what that sum is just by doing some what's called partial sums. S sub 1 is 2. S sub 2 means add up the first two. 2 plus 1 is 3. S sub 3 says add up the first three terms, which is 3.5 or 3.5. S sub 4, add up the first four terms, and that is 3.75. And S sub 5 says add up the first five terms, which is 3.875. Do you notice that these numbers are approaching 4? The sum of this infinite series approaches 4. So these values keep getting closer and closer to the number 4, so we say that the series converges to 4, and we would say the sum of this infinite geometric series is 4. There is your formula. So we can use that formula to go back and find the sum of this infinite series. This infinite series was 2, 1, a half, etc. So once it's infinite, it's just a1 over 1 minus the common ratio. The common ratio is a half. 2 minus a half is a half. 2 divided by a half is 4. Now, you can do that with the calculator, or you can do it by hand. 2 is the same as 2 over 1 over 1/2. When you have a complex fraction, a fraction over a fraction, you take the bottom fraction, flip it upside down, and multiply. But I think it's just as easy to use the calculator. So now we want to find these sums. First off, is it geometric? And the answer is yes, because of the format. That's something raised to a power. And that also makes that the common ratio. So because the absolute value of the common ratio was less than 1, then that tells me I can use this formula, a1 over 1 minus r. So the bottom of this will be 1 minus negative 1/2. The top, though, I have to figure out what a sub 1 is, and a sub 1 is plugging 1 into that. So this would be negative 3/4 times negative 1/2 raised to the 0th, and anything to the 0th power is 1, so this is negative 3/4 times 1, which is negative 3/4. So I would clean this up so you just don't make a calculator mistake. 1 minus a negative 1/2 is plus. You can use your calculator there. 1 plus a half is 3/2. And this is negative 3/4. You can flip and multiply right here, or if you want to use the calculator directly, be sure you put this in parentheses. Parentheses negative 3 divided by 4 divided by parentheses 3/2, and that works out to be negative 1/2, or the decimal negative 0.5. Because these are both nice neat decimals, you could go directly to decimals. This is negative 0.75 over 1.5, and your calculator will tell you negative 0.5. So it depends on what MathLab is asking for format-wise. To do this one, it is geometric because it does fit the format of something to a power, and that also makes r 3/5. We do have to figure out a sub 1. A sub 1 means put 1 in right here. 3/5 raised to the first power is also 3/5, so a sub 1 is 3/5. And I can use my formula, a1 over 1 minus r. So this is 3/5 over 1 minus 3/5. And you want to use your calculator directly, be sure you put this in parentheses. I would also, just to be safe, depending on your calculator, put that in parentheses. So type in parentheses 3 divided by 5, close your parentheses, divided by parentheses 1 minus 3/5, and that's going to give us 3/2. On the other hand, you could do a little bit of work on your own. 1 minus 3/5 is 2/5. A fraction over a fraction, we flip the bottom fraction upside down and multiply. So this becomes 5/2. That's out of the picture. The 5's cancel, and that also gives us 3/2.